Ooh.
All right, we're going to be simplifying and solving radicals. I'm going to explain what a radical is. A radical, we're going to be doing this under, that little symbol, okay? Right there. Be simplifying them and solving them. This was covered in most algebra curriculums, and I'm reviewing it so that, because there's, we've been a while since you did it, okay? All right. There we go.
I don't have anything.
Simplifying radicals. This is review, okay? So this first stuff will be a little bit of review. What I have in there's no fill in the blanks. It's right on your note sheets. We can take the square root of all numbers, but only some of them have what I call pretty answers, or the technical word is integers, okay? So not all of them are beautiful. These are some examples of some ones that actually come out with integer answers. The square root of 4 is 2. The reason is 2 times 2 equals 4, okay? And I've left a little space there for you to write that in there. Another one would be like the square root of 9. 3 times 3 is 9, so that means the square root of 9 is 3. These have pretty answers or integer answers. Not all of them do. These ones, this next one, they're not a perfect square root. Not all numbers have perfect square roots. For example, the square root of 21 is 4.5825, and it's going to keep going on forever and ever and ever. So if you were to ask to write this down and you wrote the answer 4.5, that would not be that would be an approximation, but it would not be the exact answer. Up here, this is the exact answer, is 2. If you wrote 4.5, it would be an approximation of the square root of 21. All right. So, even though all numbers don't have perfect square roots, some can be simplified and stay accurate. And I'm using the word accurate because I want it exact, actually. So, if I wanted to do the square root of 20, there is no perfect square root of 20, but we can simplify it. And we're going to simplify that by doing the factor tree. I'm going to counsel you on that little square there. Mine will take up 2 squares or 2 slides, but I only left 1 slide for you to do this. So make sure that when you do it, scoot your factor tree kind of close, because you're going to finish on the side, all right? So mine is going to take up the whole thing. When I did the factor tree, I did 20, and I split it into 4 times 5, and then I split the 4 into 2 and 2. So in other words, the square root of 20, I can take it, and I can write 2 times 2 times 5. What am I going to do now? Do you guys remember how to do this?
Take the doubles out.
Take the double out. I'm going to take this double 2 right here. Take that double 2 out. And I'm going to write it as a single. The partner comes out of the square root, and it's going to be 2 square root 5 as my answer. We have done this before. We're going to continue to do this even more. This chapter will have a lot of square roots, hence why we learned the geometric mean stuff prior to it. So now you know how to do the geometric mean, you know what it is, but now you're going to apply it, okay? All right, here's some square roots. We're going to now add something in there. We're going to add an addition or a subtraction, excuse me. So we're going to first do this square root 44. What is the factor tree for 44? What multiplies to be 11 and 4 and 2 and 2? Okay, so what comes out for that 44?
2.
So that'll be 2 squared 11, correct?
Mm-hmm.
All right. So 44 becomes 2 squared 11. And I have another plus 2 squared 11. I want to go back for a quick minute. When you guys were in the beginnings of algebra, maybe even in 7th grade, if you had 2x plus 2x. These are called like terms. So I can put them together. That says I have 2 x's and 2 more x's. And how many total x's?
4.
4 x's, okay? This is exactly what you have here. You have 2 squared 11s and 2 more squared 11s. So how many squared 11s do you have?
4.
4 squared 11s.
Mm-hmm.
You have right here 2 squared 11 and another 2 squared 11.
Mm-hmm.
How many square 11s do you have? A total of 4 square 11s.
Okay.
The only way you can put them together is if they are like terms, meaning they have the same radical or same square root after it. Okay? We're going to do some more examples. In a little bit, we're going to go on to multiply now. We have been multiplying actually before. Let's just go over it again. We're going to take the two numbers in front, or the coefficients in front. 2 times 5 is 10. And 2 times 3 is 6. So we will have 10 square root 6 as an answer. Be cautious, because that inside the radical, in this case, 6 can't have anything pull out, but we might be able to go over some that have some to come out later, okay? You might not be done just because you're multiplying together, but in this one you are. All right, we have, the new thing on this slide was mostly just the addition and the subtraction part. We have done this multiplication before. We're going to move on to something that we haven't covered in this class yet. It's called rationalizing the denominator. All right, there is some rule that someone made back in the day that said there cannot be a radical in the denominator of a fraction. What does that mean? What is the denominator?
The bottom part.
The bottom part of the fraction. So if you ever had a square root of something in the bottom of a fraction, you have to move the radical up. You have to get it out of there.
So reciprocal?
You can't do the reciprocal, because if we did the reciprocal, when you put this in your calculator, if you took 5 divided by square root 3, whatever you get has to be the same decimal value, or you have to keep the same value. So taking the reciprocal would change it. So we can't change the value of this fraction. We have to change what it looks like so that it doesn't have a radical in the denominator. Okay? Let me show you what that means, how to do that. So what we're going to do, so you must move things around so that there will not be a fraction in the denominator, but you can't change the value of it. It still has to be the same number associated with it, the same value. So this is what you're going to do. Here's an example that you have on your page there. And I think it might be on the next slide, Ryan.
Mm-hmm. It's on the next page.
Okay, so there was the rules there that I just wrote on that slide for you. And there we go. All right. Whenever you have a radical and you have a fraction in the radical, you can write it as 2 separate fractions. Is there a problem? Do I need to rationalize this denominator? Am I allowed to have a square root in the denominator? No, okay? So when you were doing, we reduced fractions a while ago. If I took 2/3, and if I multiplied by 2 on top and bottom, I would get 4/6. These two fractions, 2/3 and 4/6, are the same fraction. They are the same value. The way I did that was I multiplied by the same thing on top and bottom, and I get the same value. That's what we're going to do here. We are going to multiply by something to get that denominator out. And that was what we're not going to square them both, because if we squared them both, we'd change its value.
You would? Oh.
We're going to multiply the denominator by the denominator on the top and bottom. In other words, we're going to multiply by square root of 5 on the top and bottom. Square root of 5 was in the denominator, so we're going to multiply it on top and bottom. We are not changing the value of the fraction if we do the same thing on top and bottom. What is going to happen to the denominator? Square root of 5 times square root of 5 is what?
10. Or wait, 25.
Square root of 25. What's the square root of 25?
5.
5. Plain old 5. Remember when there's a double, it comes out as a single? This is a double 5. It'll come out as a single 5, and it'll be out of the radical. When we simplify, this denominator became plain old 5. How in the world did we get a 15?
You multiply the tops.
We multiplied these tops together.
Why is there still square roots among the top?
Now, read the rule again. Go back to the slide. Did it say we can't have a radical in the numerator?
No, it didn't.
Denominator. So it's okay to have the radical up in the numerator.
I was saying, why do you still have it though? Like, have to multiply? Does it have to be like a perfect?
It does not have to be a perfect square root. We are finished right there. It just can't have a radical in the denominator.
Oh, no, I was saying, why do we still have it in the top after multiplying it?
Because there was not a double. Down here in the bottom, there was a double 5. It came out as a single.
Okay.
That's a 5, not a 25.
Well, I was right in the whole.
And this, because it didn't, there was not a perfect square root,
Square
that's
root
why it's still a
25.
radical.
Okay.
Did I answer your question, Amy?
I think so.
Okay. It wasn't a double. Like the bottom down here had a double 5. It came out as a single, right? But this numerator is not a perfect square root, so it stays.
Yeah, that's what I was saying. Like, so it has to be like a double in order for a not to have a. So
That's
it's gotta
correct.
be technically like a perfect square.
It has to, exactly right. It has to be a
Yeah.
perfect square to come
Okay.
out. Yes. And that's why we chose to multiply by the square root of 5 so that it would be a double on the bottom.
Is that why you always do the number on the bottom always?
That's correct. That's correct. All right. So this one, what am I going to multiply on top and bottom for this one?
17.
The square root of 17 on top and bottom. That's correct. Multiply by the denominator on the top and bottom. Here we go. What's going to happen to the square root of 17 times the square root of 17 on the denominator?
It's gonna be 17.
It's going to be a plain old 17, but what's the numerator going to be?
5 square root of
5 square root 17. Yes.
Oh yeah, because
Because
5 is not a square.
Because 5's already out. Can I cancel out those 17s on top and bottom?
No,
Because one's under the square root. That's right. Okay. I am finished. It is 5 square root 17 over 17. I don't, but I can get you some water.
I've got water.
All right. All right. Now we're going to solve equations. You have been solving equations for a while, but now we're going to do radicals. All right? We might have even done some of this. I don't remember, but I think we might have. If you have this x squared equals 21, how do I get the squared off of this x?
Take the square root.
Take the square root of both sides. We must get rid of the squared by taking the square root of both sides. So we're going to, you don't have to write the second step. You can just take the square root on there and the square root on there. Now, there's a trick though. When you take the square root of two sides of an equation, you're going to get two different answers, not just one answer.
Huh?
You're going to get two different answers, and it's going to look like this. I'll read it again. Whenever you take the square root of both sides, you have a positive and a negative answer. In this case, I have x will equal, this little plus and this minus go together, meaning a positive 11 and a negative 11. This is one of those times when mathematicians, again, don't like to write a lot. They don't want to write it like this. They don't want to write x equals 11 comma negative 11. They want to, they simplify it all down into one little place, that little plus or minus.
Like a cross in the dirt.
Yes, it's a plus and a minus.
Yeah, cross
Okay.
in the dirt.
Cross in the dirt, I guess you could go, yeah. Plus and a minus, all right? Now why? Let's do that, let's try again. If I put 11 up here, if I put an 11 up in the square at the top up here, 11 squared, will that be 121? Yes, because 11 times 11 is 121. What about negative 11 times negative 11? Well, negative 11 squared, will that be a positive 121? Yes, I will get both of them. I must list both of them. All right?
But if you don't get both of them,
You will get-
always get both of them? or
You
no?
will, if you took the square root of both sides of an equation, you must write both plus or minus. Otherwise, you will be
I'm saying,
only
like,
half
what
correct.
if both the answers don't work?
If both the answers don't work, then you won't write both of them. Now, in geometry, many times those numbers are associated with a measurement of some kind of some side of an angle or some side of a triangle, and we don't usually get negative angles. We might get a negative velocity if we were doing physics,
Okay.
but we won't get a negative in the length of a side. So usually in geometry, we throw away the negative, but when you're just doing them like this, make sure you practice getting a plus or minus, because sometimes in your life, when you do higher level, not higher, but just different kind of sciences, your negatives will mean something, okay?
So if you get the positive 11, then the negative 11 is pretty much automatically going to work because the negative and the negative cancel out.
Yes, yes, very good. All right, here we go. This one right here, on your next slide, before we can start this one, we must get that x squared all by itself. So we got to move the 5, and we have to move the 2. How are we going to move the 5?
Add it to the other, or subtract it.
Yes,
from the
so
other side.
go ahead and do that. Subtract it to the other side. And when I take 41 minus 5, I get 36, I think. Is that what you guys got? And then we need to get the 2 over. Divide by 2. So when I did all that, I had x squared equals 18. Are you guys with me on that part? How are we going to get the 18 by itself? I mean, the x squared itself
Are
now?
you just dividing by the 2? Like,
I subtracted the 5 and divided by 2.
you subtract the 5 from the other side and then divide thing over just the 2.
Okay, this is what I did.
Like-
2.
I'm just wanting to know if I'm right on how I did this.
We'll subtract the 5, right? And we'll get 2x squared equals 36, correct?
Oh, wait. Oh, I got the wrong thing now. Okay, yes.
And then divide by 2.
So you just, okay.
Yeah, does that make sense?
Yes.
Okay, so then x squared will be 18.
I
How-
don't know if you could do that because you have like the x squared.
Yeah, so now we solved it like we did with the regular x. We're not quite done because we now need to find out what just plain old x is and not x squared. How am I going to get the squared off?
Square both sides.
Square root both sides.
Yeah,
That's square root both sides. Now, when I do that, I'm going to get a plus or minus 18. But can this square root of 18, is there a perfect square root?
Yeah.
Can I simplify it though?
Yeah, it can be simplified.
So what can I take?
Whoa. Never mind.
Yeah, it's going to be a decimal, right?
It's a really
Okay,
good number.
but
Square root 2.
we can take the factor trees, do the factor tree, and the square root of 18, when I did my factor tree, is what times what times what?
3 times 3 times 2.
Yes. And the double comes out,
X equals plus or minus 3 square root 2.
yes. Make sure you put the plus or minus in the correct spot. Make sure you don't put it in between the 3 and the square root 2. Make sure it's in front. It means something different, okay?
Uh-oh. Are we going to have to go into that?
I think you'll be all right. All right, we're going to do, go ahead and get your assignment sheets out. I like to do some with you so you can know, and you have some of them started. We're going to do about 6 together. I have written these numbers down, but you could circle them if you want. We're going to do 8, 9, 15, 19, and 22. And we're going to try really hard.
2.
We're going to try really hard to stay focused on just these, so we have plenty of time to do the next things.
Oh, wait, what is this?
We're going to go to your assignment sheet
Which one?
for the review, not,
8.1.
not, yeah. Yeah, you're almost there. Yep, there we go. We're going to do numbers 2, 8, 9, 15, 19, 22. And we're going to do number 2, we said, right? Number 2. I liked how this was, the display on this one was bigger and we could see things better. Okay. How are we going to do this?
Do the tree.
Yes. 147 is what times what? Does anybody think of anything that might go into that?
How do you figure this out easily without typing a bunch of numbers in your calculator? Random numbers in your calculator.
I pick all the prime ones first. 2, is 2 going to help us on this one?
No.
No. Now, how do we know if 3 is going to work? Remember how we can choose if 3 is going to work?
Isn't it like add multiplier?
Yes. So 1 plus 4 is 5. 5 plus 7 is...
So it could work.
So 3 can go in there. Okay, so 3 goes.
Because it'll equal 12.
49.
49. Okay. You could be done right now. Is there a perfect square root of 9? It should be 49?
49, yeah,
7. So you could stop right now and put a 49 and a 3, but if you don't want to, if you want to go 7 and 7, so you have your doubles, just for visual, I'm going to write these out. That's a terrible, my handwriting
Wait,
is
so
really
it would
bad.
just be 7, 3.
Yes.
Yeah, 7, 3.
We're going to take the doubles out to be 7, square root 3 will be our answer. Yes.
Wait, so what do you mean we could just stop right there?
We could have stopped right here. Okay, so if I would have done it like this, 3 times 49. You know the perfect square root of 9? Excuse me, 49 is 7. This becomes a 7 on the outside. And the 3 stays in. It's the same as you got over there.
Wait, I thought you were saying there was like a longer or another way to do it. That's
There,
fine.
in a sense, it's just a different way of thinking. If you didn't want to have to write this extra little bit down here, you could have stopped at the 49. Okay? All right.
Plus and minus. Plus and minus.
One more time.
Do I have to put plus?
That is an excellent question. Okay, so do we have to put plus or minus? You put an plus or minus when you had an equation. And you took the square root of two different sides. Since this is not an equation, they gave you this thing as the square root of 147, and since there's an invisible positive, they only want you to give the positive. Okay? Fantastic question. All right. I always like to come over here and I can have it tell me the answer, and it was 7 square root of 3. I'm going to turn that off. And what was the next one we were going to do? It was number 8, and I can go to 8. All right, 5 square root 1,000. Now this one's got a 5 out front. Before you even start, is 1,000 a perfect square root?
Yes.
What is
Right.
it?
Is it 100? No.
Is it
100?
Is it 100 times 100?
No.
No, it's 100 times like 10.
Okay, so there's not a perfect square root of 1,000.
No, but
Okay, so we need to.
100 goes into it. Which
Yes. So 10 goes into it, and times 100, right? What about 100? 10 times 10, right?
So it would be
You could break it down with the 2's and the 5's and the 2's and the 5's, but you don't really need to.
50 square root 10.
So this is 5 square root 10 times 10 times 10. Is there a double in there?
2 and 5. 1, 2, 1, 2, 3, 1, 2, 3. Yeah, so square root 2 and 5 once on the, or like take the outside of it and then do it once on the inside.
Uh-huh.
So it'd be 10, 10.
Yeah, see, I just did I just left them, since I had all those, you can do it that way too, or you can do your 2's and 5's and 2's and 5's. You can take out 2 5's and 2 2's.
So technically just stop with the 10s and just do the 10s.
That's what I did. But you could do the 2's and 5's and 2's and 5's. You're going to get the same answer. So these 10's are going to come out, be a single 10. But what do I do with the already 5 there?
Add it.
Add it? I heard add it. So it'll be 15?
I have a multiply. Don't we multiply?
Is it multiply or add?
It's hard.
It's multiply.
No.
Because this is, right here, this means 5 times. Right there. That's a multiply right there. So we're going to, whatever we take out has to be multiplied. So this 10 is going to come out, and it's going to be 50 square root 10.
Oh, okay.
Whoa, wait, so we can't do the 10 square root 10?
Okay, it would look like this. I'll go back. I'll write it out. This 10 is going to go there, and it'll be 5 times 10 square root 10. Then we'll simplify that to be 50.
No, I'm talking about like after you break it down like the 2 and the 5.
Okay, so I'll do it that way.
Wait,
I'll do it that way.
because then you have...
If I broke down this, Amy, and I got
Because
2
now
and
you have
5,
3 2's and then 3
2 and
5's.
5, and 2 and 5, yes. I'm going to have a 5 on the outside. How many 2's will I have, Amy?
No, 3 2's and 3
So I'm gonna
5's,
write
but
2,
you're
2, and
gonna
2,
have
right?
one outside.
And then I'll have 5, 5, and 5, right?
Yes.
These doubles come out.
Yeah, it would be 5 and 2 and then 2 and 5, but then you get 10. So it would be 10, 10. Shouldn't it?
Yes, a 10's going to come out, and a
you have
10's...
to go back and multiply by 5.
That's exactly
Okay.
right.
Never mind.
Yes. So this is going to be 10 when it comes out. But you have to multiply it by that 50, that 5 already there, so it'll still be 50 square 10. 10, almost what a
So
5.
it's 50 square root 10.
Yes. Questions?
No.
Okay, so the next one is number 9. Number 9, we're going to add some stuff. Okay? All right. Before we start, is there any of those square roots that can be simplified?
Yeah. Oh,
Which
wait,
one?
No, wait, simplified or combined?
We can
The negative square root 5 and positive 3 square root 5 can be combined.
these can combine?
Yeah.
All right. What do we do with this one though?
Just leave it there for the moment.
You're gonna leave it there for the moment. Okay. So this is negative 1 square root 5. We're gonna add 3 square root 5s. So how many total square root 5s will we have?
Too many numbers.
2.
Okay, Amy, do us a favor for a minute. Just pretend and forget that 1. Just don't even look at it for a moment. We can even just bring it down and just leave it alone. How many? I heard 2 square root 5s. Amy, do you understand where we got the 2?
Yeah. Oh, wait, you did the negative 1. 3?
Yes.
Yeah.
Yes. 27 is not simplified under the radical there.
Oh, wait, so then you do the minus. Okay.
So 27, we're going to do 9 and 3 and 3 and 3.
No, that can't be.
How did you do this?
I'm sorry. I've done it a lot of times in my life. I apologize that I went so fast.
No,
This
it's
is new for
okay,
you.
I just, like-
I apologize.
You're fine. I just want to know how to do it.
You're fine. I apologize that I went so fast.
You're fine.
27 is 9 times 3. And then I can break that 9 down some more, right? To be 3 and 3.
Oh, 9 times 3. You know your multiplication tables, so you can do that sometimes.
That's correct. And so, what does 27 become when I do the radical, though?
Oh, wait, you.
What?
3 times 6. So it'd be 9, 3. Like 9 on the outside.
I'm going to, yes, it's going to be a 9 on the outside because the double comes out as a single. I have to multiply by that 3. That's correct. It's going to be a negative 9. What's going to be left on the inside, Amy?
3.
Yes. Can I put this together into 1?
No.
Because
Because the inside of the square root is not, or the square root is not the same.
that's correct. I have a square root 5 and a square root 3. They're not like terms. That would be like having an x and a y, and they can't go together. All right.
One more of those.
We'll do, let's go to number 15, and maybe we can come back if we have time. Okay? All right, we're going to do that. I'm going to put in a 15. We're going to do these. This is a multiply. Remember that we're going to multiply the number on the outside and the radical also. So what is 2 times 3?
6.
Yes. I'm going to caution you for a quick minute. When you have that 5 times 12, I know it equals 60, but then you have to do a factor tree. So it's like you're going forward to get 60 and then going back again to do 5 and 12. So I would suggest that you don't even get the 60. Just leave it 5 and 12 and then do your factor tree as 2 and 6 and 2 and 3. And don't even worry about what it multiplies to be. I think that's like going forward and then going backwards.
So kind of just like put 2 different square roots there? Or
Pretend that there's your 60 above without even writing it up there. That way,
Oh, yeah.
yeah, see, like pretend that 60 is up there, but you don't write it. You can, it's just more steps, and I think you guys want to save time in your life. All right, so there's any doubles to come out? I heard 2s.
Yeah, 2.
All right, I heard a 2. This 2 here, right? What's going to be left on the inside?
3. Or wait.
A 3, I agree. And what else? And a 5. Those 2s will come out as a single 2.
I didn't see the 5 on it. Okay.
And I'll have 15 on the outside. So I got 12 square root of 15. Is that what anybody else got?
Yes.
That's what I got.
Fantastic. Let's check that that's what they got. Because I can turn on the little show me button. 12 square root of 15. Fantastic. Now we're going to go now. Was number 15. Let's move to 19.
Oh, yeah.
All right, now we're going to rationalize the denominator. We're going to rationalize the denominator, but before you do that, don't do anything yet. Don't do anything yet, because sometimes the word yuck, rationalize the denominator, is actually not rationalize the denominator, okay? So look at it first and see if it's actually, because that square root 9 and that square root 4 are already perfect square roots. You might not need to rationalize the denominator. That's actually one of the common mistakes, is you do all this work, you'll get the right answer, but it would take you forever to rationalize denominators and then take all the perfects. What is the square root of 4?
2.
2. What's the square root of 9?
15. Or 3. Sorry.
3.
Multiplied the word.
Is there a radical in the denominator right now?
No.
No, so you didn't have to rationalize the denominator. So make sure that you actually look if it's a perfect square root first. So then I'll have 2 over, what's 5 times 3?
15.
15. So don't let it trick you. Some of those are going to have perfect square roots, and you won't have to do that rationalizing thing. Last one is 22 that we were going to do together. Let's go. All right. Is this got a perfect square root? You can do this to yourself, though. You could simplify the 12 and the 20 and see what might reduce and see if it will be easier, or you can just rationalize right now and do the square root 20 over square root 20. You have a choice. In this world, your mother's telling you what you can and can't do and what work you have to do and what homework. No, I'm giving you a choice. You get to choose what you get to do. Plan your destiny. Choose wisely. Okay, so it doesn't matter. In this case, wisely will be the same. What do you want to choose? Do you want to take the partners out, or do you want to multiply the 20 and 20 on top?
That's what I did.
You do the 20 and the 20? All right. I'm going to do it both ways eventually. So you do the 20 and the 20. Okay, so I am not going to multiply to make that 120. I'm going to just leave it 12 and 20, but I'll have a 20 on the bottom.
240.
I understand.
Yeah,
But I will have to, that 240 up here, I will have to undo it by doing 12 and 20, so I might as well just leave them. 4 and 3, 4 and 5. And right now, I could break those 4s down into 2 and 2, and 2 and 2. Will I?
Just wait, I'm not there yet.
Oh, I'm sorry.
I was gonna anyways.
I have a double with a 4 and 4, and so I can just take the 4 out as a single. And it will be the same as if I write down the 2 and the 2. And so I'm going to leave it just 4 and 4.
Okay. Oh, yeah. You
understand?
Yeah.
Then you have all those extra numbers to do. So I will have on the top
415.
4
Square
root 15 over 20. All right? Am I finished? Be careful.
Oh, wait.
No.
No, because can I reduce the 15 and the 20?
Square root 15 over 5.
I cannot reduce those because one's under the square root, one's not, but I can reduce the 4 and the 20. Does 4 go into 20?
Yes.
How many times?
5.
5. So the 4 reduces down to 1,
So
and that becomes a 5.
square root 15 over 5.
So I will have square root 15 over 5. I won't. I told you I was going to do the other way again, and I won't. I'll just leave it. There's no radical in the denominator. You have rationalized. You're done. Are there any questions? All right, let's go back into there. Let's go back to there. Okay, this is what you guys learned today. You simplified radicals by doing the factor tree and taking out the partners. We have done this before. You simplified radicals when we added them and subtracted them, and we also did some multiplying. The new ones was the adding and subtracting today, or the review, but the multiplying we've done in the past couple days, or past couple of units or whatever. And this was maybe new for some of you entirely, or maybe it was just review from a way back in algebra. When you divide, you must rationalize the denominator so that there is no radical in the denominator. Then we just reviewed some solving by taking the square root of both sides. Okay? All right, we're finished. I hope this has been helpful. Goodbye.